Earlier, I'd mentioned that one of the challenges with using event sourcing is that sometimes implementing queries directly against the event store can be challenging. Perhaps the event store only supports primary key-based lookup of entities, or in other situations, the actual event-based representation of the state of an entity would mean that queries that needed the current state would actually be inconveniently complex. So in this section, I'm going to look at an alternative approach known as command query responsibility segregation. So let's imagine that you want to display customers and a customer and their recent orders. In SQL terms, that's equivalent to doing a join between customers and orders where orders are retrieved by their foreign key. But suppose the event store only supports primary key-based lookup. That would make it difficult or impossible to retrieve a customer's orders. So the solution that I'm going to describe here is known as command query responsibility segregation, or CQRS. And the big idea with CQRS is that rather than have one component handle both commands and queries in your application, as the name suggests, you actually split that component into two. So you have one component that's handling the commands. So these would be update requests. So in REST terms, that would be HTTP updates, HTTP posts, puts, and deletes. And then you'd have a separate query component that would be handling the HTTP gets. So we've now got two separate components in our system. And the way that they remain synchronized is through the events. So that's published using event sourcing. The events flow out of the command side through the event store into the query side. And the query side maintains one or more materialized views that can easily be queried. So if we were to look at the query side in a little bit more detail, it would implement some kind of data store or view store using a database, whatever database was suitable for the queries that it needed to support. It could, for example, use MongoDB. It could use Elasticsearch for doing text search. If it was searching social graphs, then perhaps it could use a graph database like Neo4j. There would be a service, or at least a component, that would subscribe to events being published by the event store, and it would be responsible for keeping the view up to date. There would be another component that would handle the HTTP request by querying the view store. So the big idea is you maintain a denormalized representation of the data, also known as a materialized view, that can be queried efficiently in order to handle HTTP requests. So in the example code that I have in my GitHub repo, the way I actually store a customer and their recent orders is using MongoDB. So in MongoDB, there's a document representing the customer, and that document has an order attribute that's a list of their recent orders. And so you could imagine there's code that's subscribing to the events, an order events and customer events, and keeping this document up to date. And what's really nice about this is that to display a customer and their recent orders simply means loading this document by its primary key. So that's very, very efficient. And we've accomplished that by denormalizing the data. So an HTTP request comes in for a customer, you turn around and load this document by its primary key. So the actual code that does this in the example is implemented using Spring Data for MongoDB. It's basically subscribing to various events, customer created events, order events, and then performing the appropriate update against MongoDB. So it's very, very straightforward. So that's the big idea behind CQRS. You write code that subscribes to events, it maintains a denormalized view or a materialized view of the data, and then you have other code that queries that view. And the type of database that you use very much depends on the kinds of queries that you support. As I mentioned earlier, MongoDB is a great choice for serving up JSON to through a REST API, because a Mongo document you can think of as just a JSON document, and so you can very efficiently retrieve quite complex JSON documents just by primary key-based lookup. You could, for text searches, you could use Elasticsearch or something like AWS Cloud Search. I've used that in applications that I've built. And then in other applications, I've used DynamoDB, which is AWS's NoSQL database as a service. And that sort of can be very appealing, especially because it's a fully managed service where you can dynamically adjust the capacity that you need in terms of reads per second and writes per second and so on. So that's CQRS. So there's various benefits to using this approach. So number one, it actually solves some key problems in an event-sourced architecture. It makes it possible to query the data efficiently. It also can simplify your application by separating concerns. By separating command processing from query processing, you can end up with simpler code. Right? The command processing components just processing commands. Likewise, the query processing components just processing queries. Also, this architecture supports multiple denormalized views. So rather than having one data store that actually has to deal with many, many different types of queries, you have several different data stores. Each one is optimized for certain types of queries. MongoDB for retrieving JSON by primary key, Elasticsearch for doing text searches, Neo4j for doing graph searches, and so on. So that enables you to significantly improve the scalability and performance of your application. Something to think about as you're watching as you're waiting for a slow website to just retrieve some data from a database and display it in your browser. So there are some downsides, of course. Big downside is yet more complexity. We've now got more moving parts in our system. We've come a long way from a monolithic application talking to a monolithic database. Now things have got a lot more complex, but sometimes complexity is a good thing, right? There's a big difference between necessary complexity that's sort of inherent in the problem and then accidental complexity that's unnecessary and introduces additional cost. There is perhaps some potential for code duplication. You might need the same code in both the command side and the view side, and that could be extra problematic if, for instance, the view side is written using a different language, right? Some of the examples I've worked on, the view side is written in Node, for example. And then another issue that makes your life as an application developer a little more complicated is that there's effectively replication lag between the event store and the view. So for instance, you could update the event store and then issue a query to retrieve what you just updated. That query would get routed to a view which might not have been updated yet. And so you would get inconsistent results. So in many cases, you can actually sort of work around this problem. So for example, if you're building a smart client in the browser, so say an AngularJS client, you can just update the AngularJS's model that you're rendering in the browser with the assumption that the update will succeed. So from the user's perspective, the UI is updated, And the underlying assumption is that by the time the user navigates away from that page and navigates back, which would then trigger a query of the view store, the view store will have already been updated. So that's CQRS. So there are definitely some significant benefits, but as you can see, there are some interesting design challenges that you have to resolve. But for the most part, it can be a very effective technique to use inside your application.